I was really uh, happy to see David Reaves at the NAB show this spring. He is the maker of a number of audio processors, including the Ariane, which a lot of stations adopted and placed before their normal compressor and clipper. But David is now working with the Aqua Broadcast folks and has come out with a new product called Zen 10. And David, why don't we start by you telling us the line that you give when people ask you, what does it do?
Oh, that's a good one. This is the kind of thing I have to explain to my wife's friends. It just makes things more listenable by controlling the extremities between loudness sources. So when something is too loud, it turns it down, and when it's too quiet, it turns it up. And I use the analogy of when you're watching TV, you'll turn the volume down if it gets too loud, and then you'll turn the volume back up during the quiet spots. And most people find that a bit annoying. So they would really like to have something that automatically does that, and that's what my boxes do.
I think to a degree, you also point out that it does a lot by doing nothing.
Well, that's the whole Zen idea. Um, the processor, it's actually a line of three processors I've been working on. The Zen 10 is the top of the line Zen level controller. And the Z3 is a half rack size and scaled back capabilities. And then there's the Zaudimax, which is designed to look and perform similar to 1965 CBS Audimax 3. And they're all using this, what I call Zen, which is basically an adaptation of the Audimax method of controlling levels. So I'll get into that in a minute, but I think the first thing we wanted to do was explain where I've been and how I got to what we're doing now. And that is 3 years ago, I was on a Facebook group. I'm still on it, actually. In this Facebook group, they started talking about audio processing and the Ariane and other things. And I said, I'd be happy to investigate doing some audio processing again. And so some of the people in the group said, well, okay. And so I said, well, if someone's really interested in doing this with me, send me a proposal. So I got 4 proposals, and I sent them all like an 8-page letter because I didn't want to get in bed with anyone unless I know what I'm getting into. So I sent a letter describing what I can do, what I can't do, what I want, and what I don't want. And the best person that gave me the best responses was Rich Redmond. And Rich and I had known each other since I was the chief at Z100. And during the Empire antenna replacement, we had to buy a new transmitter. So we bought a new BE10 from Rich from Northeast Broadcast Labs. And so that's how Rich and I knew each other. So we decided to meet at the September IBC 3 years ago, and we started talking, and we kind of hit it off, and we decided, let's make a go of this. And so we decided to form a company. And at the same time, I started buying little experimenter kits and stuff with the DSP by Analog Devices called Sigma Studio. Now, I'm not a math genius, and I'm certainly not a coding genius. And there are people that would claim that I'm not an audio processing genius, and that's okay. But I wanted to learn how to do all this stuff properly in digital. And the best way to do it for me was the Sigma Studio system, because it allows you to do everything graphically. They have symbols for summation and division and all the math things, logging, etc. And then you connect it all with wires on the screen. And then you send that to the DSP, and it sucks it all up and allows you to then add your audio to it and listen to it on the output and make adjustments. And so that's what I spent the next couple of years doing was just learning how to do the Audimax on that. And in the meantime, Rich and I decided to form a company, and we called it David Reaves Audio LLC. And we looked for someone to do the manufacturing because there was no way I was going to take care of manufacturing. That's one of the things in my 8-page memo was I'm really not interested in supervising the mechanics of things. I'm very happy to come up with designs, but when it comes to producing hardware, we need someone who's good at it. And that's how we ended up with Aqua Broadcast. And the guys are here. Pavel and Brendan, I see, are both here. And I'm sure they will have plenty to say about this project, which heavily involves their input. They've created a framework that allows the inclusion of other ideas into it. And it's a really cool idea, and it's very powerful. And I will leave it up to them to describe it. But suffice to say that the Zen 10 relies heavily upon the capabilities of this new device that they've created.
Well, that's a good background. Appreciate that. We had Brendan here and another of his helpers a few weeks ago, and now you're part of the same team, which is good to hear. I can make the screen available to you if you would like to show us something, or if you just want to go on and describe things.
Well, if Pavel and Brendan have nothing to say, then I'll just continue with my little promotion here. This is what the device is going to look like. It's a one rack unit, and with a large display in the center and then a control display on the right side. And multiple connections on the left for USB and for headphones, and then a scroll wheel on the right side to do all the control. And of course, being modern, it has the capability of being controlled remotely by HTML, so that's a given. The background of my product is this idea that the CBS Audimax was an amazing device that was left behind when the Optimod and the other processors came in the 70s and 80s. Now the CBS Audimax had the original the original tube model, and then the Audimax 2 advanced that with the return to zero, and then the Audimax 3 eliminated the tubes, all except for one little new Vistor, and then the later multi-channel Audimaxes in the slimline eliminated the tubes altogether and mostly used transistors and integrated circuits. Now the thing about the Audimax is that it's not your regular audio processor. What CBS said was, applicable to all media, the unique Audimax system of audio control developed by CBS Laboratories is totally different in concept from ordinary compressors, limiters, or AGCs. The Audimax acts like a highly capable studio technician, but without many human limitations. Valuable in the studio, the Audimax is often more valuable outside, away from controlled studio conditions. The ability of the Audimax to act instantly and control audio levels intelligently frees engineers to cope with the many other problems of remote pickups. And then they go into the gain platform, which is the real secret to the control of the Audimax. The gain platform principle permits gain to remain on a stable plateau over a wide range of input levels rather than continually allowing it to rise and fall with consequent distortion, thumping, and pumping in audio holes. Its unique gated gain stabilizer acts to bridge through program lapses and thus eliminate swish up of background noise. Special return to zero function returns gain to normal during standby conditions. So this is a view of what the Audimax's platform system does. Here on the left is an audio rectified and filtered waveform. Here on the right is another audio waveform. It's identical, except for the one on the left is boosted by a certain amount of volts to separate it from this one. Now, in the case of the processor I'm designing, you can adjust this, and this defines how much dynamic range you're going to allow to pass through with no change. Now, this middle indicator here shows the platform. That is, as long as the audio remains between these two waveforms, it will continue in a straight line. So let's see, I can give it dynamics. So this is the 6 dB higher is on the left. The platform audio is in the middle, and you can see that it goes down when the one on the left goes down, and it only goes up when the one on the right goes up. So it gets pushed back and forth between higher and lower, but only when it exceeds the extreme, in this case 6 decibels, between the two voltages. So what ends up happening is that the audio has no audible changes quite often. Like here you see several of the platforms. It makes a small change, then it comes back and goes back into the platform again. Meanwhile, the audio is varying quite a bit, as you can see, and that is continues to the output. The audio doesn't change. The audio is just held at this particular gain level. So viewed dynamically at the same time, this is a kind of an overlay that I made it does kind of the same thing. The red is the control voltage, and then the upper one is the 6 dB higher, and then the lower one is the normal level. And then as long as the control voltage remains between these two levels, it doesn't have any change. But as soon as the upper one pushes it down or the lower one pushes it up, the control voltage changes to the new platform. And this can be adjusted any way the user wants it, with a really wide platform intake or a relatively narrow one for less dynamic range of the output. And as most people know, the CBS Audimax had a resistor number 76, R76, which was famous for its being the release speed. And it came stock at 10 mega ohms. And they recommended that if you wanted to speed things up a bit, you could go to 3 mega ohms. But everyone went to like 1 mega ohm or 700K even, which was a little outrageous. But the 1 mega ohm is the one that really cranked things up. It was a really an amazingly magic processor, because you have it controlling things up and down and often, but most of the time doing nothing. And this is where the Zen name comes from, and we kind of stole it. Zen, in this case, means doing something by doing nothing. So we try and make it so that the audio can be sent from input to output with as little change as possible, and only touching up the audio's change when it goes to an extreme outside this window. This is a process that was similar to that used, the Texar used a similar process in 4 bands, and then the Ariane also used a similar process in 4 bands. Now the Zen 10 is going to use all of this this type of technology to control the audio in 5 bands, but also in 2 channels. So there are 10 identical processors that all do the same thing, but are all controlled differently. They are set up in 5 bands with 2 controllers per band, left and right, or left plus right, left minus right. You can set each individual band as either a linked stereo mode or in a matrix mode, so that you can control the stereo width dynamically. And this is control. This is not enhancement. You can actually make the left minus right less aggressive than it comes from the source material, or more consistent. And it's pretty flexible. And then at the output, there's a peak processing to control everything and keep it from clipping. As you can see, if you took a look at the upper left, input select has analog, AES digital, and Dante AES 67 inputs, and they all are bypassable, hard bypassable, so that when you unplug it, the input goes directly to the output. So in case there's a power problem, you can get your audio at least to go through without having any silence. The perfect declipper is after that, and this has a bypass, but you can use this to remove some clipping from over-processed audio if you like that, and it has all the capabilities and all the adjustments that the original Perfect Declipper app has. Then there's a tunable high-pass filter, which can enhance the very low end of the lowest octave, or you can use it to remove more energy on the low end. This goes into the 5-way crossover, which is a subtractive type filter using first order low pass, and then that is subtracted from the original to create the high pass, and we do this a total of 4 more times to create 5 bands. And so the input always sums up to be identical to the output by the nature of this type of crossover. The crossover is also optionally sent through a BS 1770 loudness contour EQ to make the processor more sensitive to the loudness curve as recommended by the EBU's BS 1770 for loudness. Then the output of the crossover is 5 bands. Now you can use it as a 5-band, or you can use it 4-band, 3-band, 2-band, or even a single band just by changing your selection. So if you feel like you have source material that really doesn't like to have lots of dynamic EQ, then you can use fewer number of bands and then set it up according to that type of material. Or you can use it more aggressively with the 5-way crossover, and these crossovers are adjustable over a short range. Then the output of these 5 crossover outputs all go to what I said earlier was these 10 identical processors. And this is where the linked stereo or the matrix stereo is chosen. And then you have numerous controls for each of these processors. Some of them are common to both channels, others are separate for, in the case of the left minus right, left plus right, you have separate control for the left plus right and the left minus right in each band. The compression ratio is, I previously thought that 1.5 to 6 is a good possibility, and I have since been experimenting with other aspects, and because of the platforming, I think that it's possible and allowable to use even a higher ratio if someone wants to, so I've made it so that you can go as high as a 10-to-1 ratio or down to 1.5. When you're down at like 1.5, it's very, very subtle, and anything below like a 3-to-1 ratio is very difficult to hear at all. And that has its place because it really does a lot of work, but at the same time, it's extremely subtle. The release speed can be adjusted anywhere from 1.1 dB per second to 10 dB per second. And this is also individual on each band. The Zen platform is from 2 to 12 dB wide. The demo I showed you on the video earlier has them separated by 6 dB. The original Audimax had 7 dB of dynamic range, and I have tried experimenting, and 2 dB is very narrow and probably not really recommended, and 12 dB is too much to do a whole lot of good, but anywhere from 4 to 6 dB of platform is really very excellent for control, but at the same time sounds very natural. There's also release gate, just like on the Audimax, and this release gate is also adjustable. You can set it from -10 below operating level to -35 below operating level. And this is what they were talking about when they said to eliminate the bringing up the noise between words when someone is speaking, or to bring up low parts where the intention was not to bring that low part up to a higher level. Another feature that I've added is called punch, and this simply adds a little bit of attack to the output to make it sound a little punchier. And that's adjustable on a range, just an arbitrary scale from 0 to 10. And each band output can go 0 dB to minus 10 dB with reference to the others. And the main output dB reference is from minus 26 to minus 15 dB LUFS. So on a loudness scale, it allows you to get pretty loud, but not massively so. Now the stereo peak protection is pretty unique. I designed it to be as unobtrusive as possible. Everything that I do in the decibel domain. And in the case of the peak protection limiter, I use an absolute value determination for both channels, and I take the higher value from both channels, and I use that to control both channels. And the way it works is a variable ratio, so that when the audio is like 2 or 3 dB above the clipping point, I reduce it at a ratio of 2 or 3 to 1. If you go up to like 10 dB above the clipping point, then it reduces the audio at a 10 to 1 ratio. So it's always attempting to use the lowest ratio, which is also the least audible whenever possible. And then, of course, the outputs are summed and sent to all the outputs: an analog output, AES digital output, and then the Dante AES 67. And that's pretty much it. The hoped for a market for this product is anywhere you need level control. And this would be in a broadcast environment for streaming, or for broadcast, or for any type of web presence where you need to have audio coming from variable sources and you need to control it. Also in production, there are plenty of uses for an AGC. Inputting music and making sure it all stays within a certain range is one thing, and there are plenty of other uses for it also. So that's kind of the introduction to the Zen 10. We're going to be presenting at the Aqua Broadcast booth the 12th through the 15th of September in Amsterdam. So I'm looking forward to going there, and hope to see a few old friends, and hopefully some of the people that are here today.
That's all pretty interesting. David, you're still located in Europe, correct?
Yes, I'm in Germany.
Oh, we moved down there. Okay.
I live in a small town called Recklinghausen, where my wife Ariana is a concert violinist.
That's somewhere between Dusseldorf and Bochum, isn't it? Or
it's around that area. Yeah.
yeah, very nice, very nice. Anyone have any questions for David here about what he's done with the audio processing, or maybe you have a question as to how it might affect your audio? Press your space bar, use alternate A to open your microphone, and or you can raise a hand. I think David, you've explained it fairly well.
AGCs have a bad rap sometimes. They're seen as not really necessary, and actually can be quite intrusive if they're not carefully designed, because they can actually fight with the subsequent processing if there is any. So this design is intended to not do that. The whole background is focused on not doing that. It's a AGC that's meant to put the audio in its place and then step back.
Well, that's a good point. And if you go way back to when we put out the first 3-band audio processor back in 1970, 71, that was the goal that was set, was to make sure that the processing started out by not moving things around too dramatically. In fact, those of you that remember the fact that the clipper was simply a diode. It was not meant to clip very much. And we were bringing up the RMS, roughly, 35, 40% to 80, 85%. And that was the big change. Then you move along through history and we get into the modulation wars, and all the thought into clean audio went away. It just wanted to be loud. And when you built the Ariane, I thought it was interesting because you kind of tried to pre-correct, to use a TV term, audio before it got to the processor, or would you say that?
Well, I just wanted to give the following processor something consistent to work with, but something that also resembled very closely the original audio in that the processor isn't seeing anything unexpected. That the processor is getting what it thinks is just normal audio and treating it as such, but it's just more consistent so that it doesn't have to go out of its way to make a huge correction either up or down. It just can find its sweet spot. We all know the Optimod 8100 had this sweet spot like around 9 dB of compression in the main AGC. And this is true for a lot of audio processors where they have this particular sweet spot where if you can keep the audio in that range, it really sounds consistent and good. So
Sure.
that's kind of what the Ariane was for. And that's pretty much the thing that we've taken up here too.
Yeah, that's quite true. I remember very clearly that we always had to watch the input levels to the different processors, and they were not always the same. And when you hit the right place, processor would work well. If you didn't, well, other things happened. Kelly, I see your hand.
Yeah, thank you. Great presentation. Thank you very much. Question about what the market is for this. So, as Barry pointed out, back in the day, Ariane was ahead of like an Optimod 8100 or whatever. And nowadays, stations that are running HD as well, you've got the all-in-one processor that's got the delay built in and et cetera. So, cascading processors really doesn't work anymore for, your typical FM station that is running HD now. So is your market more like a mastering market for your AGC? Because I don't understand what the broadcast application would be.
Well, the broadcast application is for anyone who is not completely satisfied with the way their main processor is working, particularly if they've spent a lot of money on something and it's not really doing what they want. Now, you can do a lot of things with the current processors today, and I would not argue that at all, that most people would probably be happy with what they have. But when you want a little more control and finesse, the ability to do things such as this stereo matrix control on a band by band basis allows a little more fine tuning than you would get in your typical processor. And then when you have people who don't have expensive processors and they need a little help because all they have is just a wideband AGC, then this product can kind of take them to the next level without having to purchase a new, completely new processor. And the list price for this is $2,200. So it's really not a very expensive piece of gear to put on if you have, say, a $4,000 or $5,000 processor and it needs a little bit of help.
So it's more for, potentially smaller market stations that don't have the horsepower of a modern all digital processor.
Or for those who really want to have really fine control.
Okay, thanks.
And that's really the dichotomy, if you will, in audio processing. Do you want to let the box just run and, you know, use a preset, crash out the highest level of modulation, or do you want to customize for your format? Because some formats, classical would be a good one to mention. Are there any easy listening left or beautiful music? I don't think so, but maybe on a stream. And you want to go a different direction. And especially if you want to format your audio for the medium. Radio is going to be different than streaming. Analog FM is different than digital FM is. many stations have found out.
Well, and to that point, Barry, I would see that another application for this would be for streaming, where you're not going to use audio processing in such an aggressive manner because you have to compete with other streaming operations that aren't processing like radio typically does. So where you don't have to do the hard limiting to stay within your real estate, this might be a good application as a streaming processor too.
Well, in Boston, in easy listening, years and years and years ago, we used the Automax and Volumax. We had a great sounding radio station.
Yes, and for the time, it was a great pair, the Max brothers. Of course, again, any kind of a record that had a heavy bass, drums, bass, etc. Now the audio in the middle is just going to start bouncing back and forth in time with that bass end. And that was one of the basic reasons the multiband audio processing really became so popular so fast. Brendan,
Well,
I see your hand there.
Hi, yeah. Just going on basically, with the usage, obviously traditionally with other similar types of products, people have used them before, things like Orbands and Omnias. You're still getting people even with using some sort of AGC Ariane product on the front of it. It's just basically because I'm going to put it out there. My hearing is not the best. Okay, you guys can tell me all sorts of things, but I can hear when pumping's going on with audio, and I can hear aggressive levels, and it really, really annoys me. When you have a product like this where it just tames those levels out, we talk about easy listening stations. It just, for my hearing, and I have tinnitus as well, it's quite appealing to me. Again, all processing and everything is quite subjective. I've, David's a friend. I've known David for I think 18 years now. So yeah, I know what other products he's done, what they achieved in the market. This type of product, obviously, quite a lot of FM stations. Geez, you could use it as far as I'm concerned in conference facilities, sports broadcasting. There's wherever there's audio, this product can work. It depends how you use it, how you set it up. There's a lot of technology behind the hardware of the Zen 10. Maybe my colleague Pavel, who's the principal architect of the hardware side of this product, maybe he can explain a little bit more, and possibly with David as well, on just what the capabilities are. I mean, it's not just a box with a piece of software in it that does stuff. It's a whole lot more.
I'll approach it from this direction, Brendan. You, as Aqua, have an audio processor that you sell. Now you have the Zen 10. Talk to us a little bit, or ask David to talk about combining them.
Probably that would be a Pavel question. I'm not sure how things are possible from a technical point of view within the hardware.
Okay, I'll join in to explain. Combining the, let's say, traditional processing or even software-based processing with David's leveler, Zen, it's totally possible. And I hope I'm not going to reveal too much. It's something that's being discussed in the background as a possibility going forward. Just to explain, we as Aqua Broadcast are not selling processors yet. What I was going to say a few words about is that we have designed, I would say, a quite capable platform, which is then going to be turned into multiple models of different products. Processors of various hardware combinations and capabilities, one of which obviously is going to be David's Zen, and the platform being quite capable of accommodating various requirements, functional requirements, connectivity requirements, etc., etc. So if there are no other questions, I'll just quickly jump onto that. Do a very quick presentation, and then allow for more questions. So if I may to share the screen,
We're ready.
which is this one, I think.
Yep.
Right. Okay. So I will start with a close-up on the Zen 10 front panel, where we have a small control screen for the menu, which is kind of similar to the Cobalt, which we presented last time, and a nice high resolution widescreen that takes majority of the front panel with all the metering and stuff. When I said the platform is quite capable, I will just give a brief overview of what the platform consists of, and of what it can do from the hardware perspective. So the control system, let's say the digital side of things, is built around industrial model of the Raspberry Pi. This time it's the latest version, Pi 5, and with all available connectivity in terms of network. So we actually have two Pis fitted there. I'll just start explaining the purpose of the first one, and I'll slowly move on to the second one. So the first Pi is, let's say, a system control in a similar manner as in the Cobalt, and this time it has two independent network connections. So for security reasons, if you want to have a different network connections for data control and potentially for audio streaming, then that's totally achievable. And then a standard set of, like, USBs and UARTs for remote control, local communication, stuff like that. We also fitted the slots for the expansion storage, SSD modules. And the second Pi has a totally identical set of these connectivity and expansion features. Why are there two Pis? Again, similar concept as with Cobalt, one for system control, and the other one is free to do anything that the customer would want. It's actually not that simple, but for example, if there is a software processor, something like a Stereo Tools or anything, these days there is a lot of stuff that people who have a little bit of experience with Pis or Linux, they can put on their thing and easily integrate it into the whole product, like streamers, media servers, stuff like that. So the options are unlimited. On the digital side, we also have an FPGA, which does all the like audio routing, handling, partially processing in terms of like conversion, sample rate conversion, upsampling, modulations if necessary. And there are also some expansion slots for USB audio, which is more intended for to expand the number of channels available to the Pis. So, for example, if the platform would become a multi-channel processor, and I'm talking about 816 channels, it would be totally possible to do that. Dante AES67 connectivity, and an expansion audio processor, which is a slot that will take a card with David's Sigma DSPs, and also for some models that are already planned as Aqua Broadcast processors, this slot will take another module with more DSPs to expand the computational possibilities. There are some connections to the front panel for the screen, the large screen, the front panel controller, the user interface, and stuff like that. And because the large screen is also driven from the Pi over the HDMI interface, it's also possible to extract audio from the HDMI interface to send it back to the unit for processing. Again, just to expand the possibilities the product has in terms of audio channels. And then the second half on the right-hand side is what we call like an audio board. That can vary between models. So the digital side is kind of always the same, while the audio side can vary depending on the target product requirements. So for like processor, broadcasting unit, leveler, there's most likely be a standard set of audio interfaces, so analog audio in and out. For processor, FM processor, there's going to be MPX, pilot RDS in and out, and of course a digital audio or digital MPX in and out, all squeezed into the back panel on this board. For FM applications, there is also an expansion slot for an RDS encoder, to make it complete. So in this current configuration, the system is completely self-sufficient in terms of audio MPX connectivity, RDS generation. And the reason why these two functional blocks are split is, as I mentioned before, the analog board can be replaced with anything. So we have a plan, again, hopefully I'm not going to reveal too much. We can turn it into a multi-channel tuner. So for example, for recording processes, this is what the SSDs might be useful for. So for continuous recording, multiple radio stations or streaming stations. So again, the options are unlimited. When David mentioned the bypass functionality, this is this little card up here with the relays. Backup solution or more like resilient solution. So if there is a failure, power failure, the inputs can be connected automatically to the outputs. So the bypass is always functional. So with a power loss, an audio signal can always go through for analog MPX as well as digital signals. So this is the platform from the inside. Please raise hand if you have any questions or you want to ask anything. And here I just put together a quick overview of what the audio processor model is going to be with Zen, and then I'll also show you a few more examples. So Pacific is going to be a 6-band processor, which is sort of hardware based, or low level implemented into the DSPs, within the DSPs, there's an option, or will be option, there will be a product of with a software processing, and so below the Pacific, I've shown the back panel with the connectivity. So to expand the let's say the usability, there are also HDMI outputs from both Pis, so you can connect external screen if necessary. For example, if there's something running on the second Pi, you want to put it on screen, either for normal operation, configuration, stuff like that. And as I mentioned before, multiple network connections, USBs, and the standard UART for the system, for RDS. Similar to the Cobot, there's going to be option for a DC input or to run the product from a DC power, and also as a measure for redundancy. And when I mentioned there's already multiple applications of this platform for different products. So there's also going to be a processor in a consumer hi-fi market, which is not going to be rack mount and look more like something you can put into a living room. And yeah, that's about it.
Is this going
So
to be a cut down version of the Zen 10?
Not necessarily. So when I said it can be used for anything, any kind of processing, any kind of application. I'm talking about, outside broadcasting, outside radio, outside professional application. So when it comes to Zen 10, it's up to David, into which products he would be happy to deploy the processing. Apart from that, you know, I don't want to
Let,
repeat myself.
let me ask it this way.
Yeah.
David, you may want to comment as well. One of the biggest complaints I have is that I will maybe fall asleep watching the late news or something. And about 2 o'clock in the morning, the cable company runs its local drop-ins at about plus 20 dB. This to me is, it would be a violation of the Calm Act that was put into effect by the FCC for televisions, but cable doesn't have to deal with that necessarily yet. Is this something that the Zen 10 might be, or this other one that you just mentioned, Pavel, would be especially beneficial for?
The idea certainly is. The question is whether the people that are making set-top boxes want to implement something like this. There's a lot of things like midnight audio controls that are meant to control loudness. But just like all these big box audio processors, they all start with a wideband AGC, and they go up and down, and you can hear them. So
I saw one at was either NAB or CS about 5 years ago that was designed to take the audio from your television and to do what you're talking about, so that in the middle of the night or the middle of the day, you're suddenly not rocked out of your chair or bed or whatever by an abrupt change of. I mean, I've measured it at 20 dB on occasion.
I know exactly what you're talking about. And I wrote a paper that I presented at the AES about 15 years ago saying that I was hoping that the industry would move the processing to the very end of the chain. That I think it should be in the smartphones. I think it should be in the set-top boxes. I think that the audio going out from a broadcast station, ideally, it's at least 16-bit and 44.1 or 48 kilohertz sampling rate. This is very nice audio to listen to. And if the loudness variations are too much, then I think that the place to put that is at the consumer's endpoint, because it would work really well to control all of the inputs, the CD player, or if people still have them, DVD or whatever, all of the different things coming into the streaming box have different standards for loudness, apparently. And it would be really nice to have this thing right after the volume controls, or right before the volume control, actually, so that when you put the volume to a certain position, it stays there, that you don't have to get up and change the level or whatever because of a change in the source.
Yeah,
So,
there are two factors: the level and the intelligibility, with
right,
voices being
exactly.
pushed into the rest of the audio. I
Right.
think that you can sell a lot of these at cable companies.
Probably that this would be a good place for it to normalize things, but without being normalized sounding. This whole proposal here is to do as much as possible, as cleanly and as unobtrusively as possible. So this leads to lots of different possibilities.
Over on I'm sorry, on YouTube on our live shot, James Marable says, as a consumer, I have been looking for an audio processor that would control the TV, ideally at consumer price points.
Exactly.
There you
I
go.
don't think anyone wants to spend $2,200 for their stereo. Well, outside of some of the people here. I think there are limits to how much money people want to put into this. This is why I think it ideally would be part of a set-top box, like an Apple TV or whatever else people have their TVs plugged into. This should be something right at the end of the line, and it should be an option that shouldn't cost thousands of dollars. It probably, it's probably like $100 option or a $200 option. It should be something reasonable. And I think that I would be very happy if I could find someone that wants to license this Zen level idea for TV set-top box, and I would be very happy to work with anyone to get this thing into a place where the consumers would have access to it at a reasonable price point, and something that would actually do something.
I think you got the point there. And James writes back here, audio processors directly in consumer equipment is exactly what I am looking for. Maybe Sony, maybe Apple will be the one to go to.
Well, Apple would take my idea and claim it's theirs and then not pay me for it.
Yeah, I understand. You got to be careful in licensing. Okay. Any other questions for David or his friends there before we let them go? I think you guys have really explained it well. I think it helps a lot of folks understand a little more about the dynamics of audio processing than perhaps they had thought about before. Because when you dig into audio processing, it's not as simple as an automated machine turning the pot up and down for you.
May I say something very briefly, Barry? I just want to say hi to all these people I can see on my screen here, people I haven't seen in decades. And hello, and it's great to see you, and I hope you're all doing well. I had a little medical emergency earlier this year. I was diagnosed with advanced prostate cancer, and I had to have a surgical procedure. And so the progress of my product has been stymied by my inability to do anything for a better part of 2 months. But I'm back in the saddle now, and it's really great to be alive, and it's really great to see these old friends and partners, and hello.
Well, we got a whole bunch of them, and they're all happy to see you as well, and glad that you're still busy here.
I have a quick question for David. David, I understand you live in Germany. Have you learned the language?
Ein Teil, a part. My wife speaks really good English, so I haven't had to learn German, but I have. I spent 3 years in night courses to learn as best as I can. I know how to find the restrooms, and I know how to order a beer, and I can buy a train. So
ja, ich auch. Ich war in Los Angeles geboren, so ich spreche kein Deutsch.
Ah, gut.
All right.
I would also like to say that I think your product would probably do real well if you can get something going in the consumer market, because I have a problem where now in my old age here, I watch more movies than I used to. And the movies start out with a loud introductory music. Then it drops down to the normal speaking level. And then in the movie, they start whispering. And I'm going up and down with the volume control all the time. So if you can come up with a consumer version of this, I would be interested.
Okay, that's exactly what we would like to do.
Yeah, it happens to me a lot. And I figured out that especially things like Netflix, they're assuming you're using 6 channels, and when you don't use 5.1, it sounds terrible, and I just having to keep turning up the volume.
Yeah, I have an arrangement where I have a device that connects to my TV set that then by wireless feeds it to my hearing aids, and that works real well. But I have a control device for that where I can regulate the volume. And I'm about to wear that thing out with going up and down so much during a movie.
I hear you. The difficulty for me would be to find a way to control 6 or 7 channels or 8 channels, depending on the format, of surround sound economically. Because we could certainly do it with a couple of chips, but once you go beyond stereo, the the cost of the production of the piece of equipment escalates pretty much arithmetically according to the number of channels that you're processing. So whereas I could probably create something for $100 that would do good for stereo, the fact that so many people are expecting 5.1 or 7.1, that would really involve a lot of channels. I mean, if I did five bands of 5 channels, that's 25 bands total. And
Yeah, well, I I have only 2 ears, so just stereo
I
would
hear
be
you.
fine for
Right?
me.
I know. Yeah. Well, starting with stereo would be a good spot to begin.
Yeah, yeah, I think you could sell a lot of those.
Yeah, I have found out that shutting off the surround sound on my TV in my living room makes it much more intelligible most of the time. Bad surround sound is, I'd rather have good mono, to be honest with you.
Yeah.
Absolutely.
You're watching the
You're-
news or something, really, you need voices coming from behind you every now and then just to keep you awake.
A couple of years ago, a company out of Japan put together a speaker system for televisions where you could switch it so that the voice area was augmented and lifted above the background music and such. The This is something that a lot of people would like, and of course, it helps those whose hearing are starting to roll off at the upper end. But you go back to KHJ in LA when the microphone in the control room and then other stations, they took that 2.4 to 2.7 and boosted it, and it cut through the music a lot better.
That's what the CBS Labs dynamic presence equalizer did dynamically.
Right, right.
That's another product that probably could be reinvestigated because it did something really, really useful. Like you say, it enhances intelligibility, and that's very useful.
Well, we certainly ask you to stay close and keep us up to date on the things that you do and the way that you maybe spread out this technology and adapt it and make it available.
Thank you for inviting me. It's wonderful to be here, and I'm very happy to share this information because I think I have a good product, and I look forward to explaining it to people and letting them hear it and to letting them try it and see if they can find some use for it. And I'm pretty sure we're going to do pretty well.
Having tried to adjust a CBS dynamic presence equalizer so that it would somewhat consistent in how it did things, David, there would be a great opportunity for a more controllable version of that. At least I think so.
Yeah. Well, you can do a lot of that in the context of something like a Zen 10. Any multiband processor allows you to focus more energy in a particular band, and you just decide, well, I'm just going to focus that energy in the audibility, the intelligibility band, between 2 and 5. And you could do that pretty easily with the Zen 10, but that it's not dedicated to that particular purpose, but it certainly can do that.
Yeah, it's getting it to do it on the particular voices
Right.
that you want it to work on, not on everything.
Well, if something's muffled, then you can analyze it and realize electronically that it is muffled. So it's not impossible. It does, like you say, it does take a little finesse, but I think it's something that we could certainly figure out a way to do. Making a preset for the Zen 10 that focuses on the human voice loudness would be probably a pretty simple thing to do.
Well, thank you, David. Thank you very much. A hearty Dankeschön to you and your folks, your workers there with Aqua. And we hope to have you guys back with us again before long.
Thank you. Thank you very much.
Thanks, Barry.
Yes, thank you.